Hi everyone. So my name is Mukmin. So I'm here to present my answer for the TAP GIG assessment. So without further ado, let's look at some of the recap of the requirements. So number one, the infrastructure must be provisioned automatically without manual intervention, and the web application should still be up. So there's meaning high availability if a AZ fails. It should be load balanced across multiple AZs, and must be without manual intervention, and design should be with best practices of security in mind. So with that, I have a few assumptions. So the first assumption when we say no manual intervention, right, is what I assume is that we do not have to require to log into the AWS management console, and we can automatically provision the AWS resources using maybe Terraform, which I'll be using later as the infrastructure as code. And from the requirements and the document that was sent, I saw that there's this sentence saying migration of on-premises workload to AWS cloud. So from here, I assume that it's going to be a simple lift and shift model, but we continue to use the Windows Server 2019 platform that has been previously using, right? And there's also another line that in the document that said that we want to assist the engineers to come up with a template for provisioning of simple web application, right? So here, in my design considerations when making this infrastructure, I was thinking, okay, we just do something simple that the engineers can quickly recreate, spin up, then after that load their application in, right? And lastly, based on the requirements from the previous slide, we see that there's importance on high availability, and you want the load balance to be across different AZs, right? So that's something about performance and some basic security. Yeah, so from there, I assume that this is the use case of a production workload, and that cost might not be a priority for now. So maybe the priority as a template is to just quickly get things up and running, and we can quickly migrate simply using a lift and shift. Yeah, so without further ado, I'll show you this is the infrastructure that I plan to create with Terraform. So let's do this instead. Let me change to this. Yeah, so okay, so on my left of the screen, maybe we can see the infrastructure itself. Oops, that's too small. Yeah, okay, so I'll go through the resources that will be created using Terraform, which we'll show later. So first of all, we create a brand new VPC, right? We call it TAP-GIG VPC, which can be seen here, right? So this VPC will obviously be created in the Singapore region, right, as necessary. And within this VPC, we'll create a total of 3 times of public subnets. So each subnet, why 3 is because we have 3 different AZs in Singapore, right? So we'll have 1 subnet each in each availability zone. So if 1A will have public subnet, and then subsequently we also have a private subnet, right? And we can see, okay, so 3 times each, right, of public subnet and private subnet. And we'll have just 1 internet gateway that's needed, and then we'll have 3 times of NAT, network address translation gateways. Why we need 3 is because we preferably should have 1 NAT gateway in each public subnet so that your EC2 instances can talk to the outside, to the internet, right? And why 3 is because I think better to for better isolation. So 1 NAT gateway in each public subnet, right? And then subsequently, my Terraform code will also create 2 security groups. So the first one, this TAP-GIG ELB, this is for the load balancer, right? For the classic load balancer. And the second security group is for my instances, right? Okay, then later I'll put a screenshot of the actual VPC that's created and the networking with the route tables and everything. I'll put the screenshot here once the infrastructure is loaded. Okay, next. Okay, we look at the compute resources that we're going to use in this infrastructure. So mainly I chose Elastic Beanstalk because Elastic Beanstalk, in my experience, it's quite simple to use. It's easy to, because most of the things of the infrastructure is managed by them, right? So with my Terraform code, I will create 1 Elastic Beanstalk environment called TAP-GIG ENV. And this Elastic Beanstalk environment, okay, in this diagram here, right, you can see that it will create automatically 2 important things, which is the classic load balancer, right, shown here. So this classic load balancer is connected to 3 of the public subnets that was previously created, right, and it routes traffic from internet to the EC2 instances. So in this classic load balancer, I also have the cross-zone load balancing turned on, so that with each traffic that comes from the public internet, it will be routed into the different AZs to different instances. So in terms of performance, it's much better, right? You won't clog up. And I'll create one, this Beanstalk environment will also create for me a one-time auto-scaling group. So in this auto-scaling group, I just put very simple requirements that I want to have a desired size of 2 and a minimum 2, then maximum 2 lah, and maximum 4. So in this architecture diagram, I just simply show at least 2 instances in any of the 3 private subnets, right? So in this sense, you have high availability. So even if one instance fails, you still have another one. And because the auto scaling group settings, it will create another one in the any other AZ lah, right, to replace it. So yeah, that EC2 instance, we just kept it simple. We just use the Windows 2019 server that was required as part of the requirement, right? And yeah, so sorry. Oops. Yeah, okay, so we move on. Okay, CI/CD pipeline, this is something a little bit extra, I feel. We have a GitHub repo. So this is where I assume the engineer's application code will be stored, right? And then create a very simple code pipeline that will fetch the source code and automate this whole process. So code pipeline will help me deploy the application code into the EC2 instances, right? And I highlighted this box here. I'll have code build and code deploy also. Because I'm not sure what kind of application the engineers will use. So I assume it's just maybe a .NET application, which makes more sense, right, if it's a Windows platform. So yeah, code build and code deploy, I just put it here just in case, because I'm not sure if if engineers are going to use it, but I do have them on standby in case we need to use them. But anyway, yeah, let's do the demo, right? So okay, in here, I have my Terraform code, right? Which is showing all the resources that I plan to create. So, okay, without further ado, let me run Terraform apply. Yeah, they'll ask me for a GitHub personal access token. So, yeah, so the disclaimer here, this is the only part where I will say it is not automated. So you still have to put in your GitHub access token. So let me get it here. Okay, after I enter, yeah, so we see that there's 39 different resources that's going to be created within our infrastructure. And I just want to say yes. Okay, now the creation process will be made. And if you all notice, I haven't logged into AWS Management Console or everything, but I do have it on standby here. So I have not touched the Management Console. So this is part of the automation process, right? And then here, I'm going to pause the video because I know the Beanstalk environment, it takes like about 5 minutes to create. So I'll pause and then I'll come back when it's like more or less done. Hey, hi everyone, I'm back. So yeah, you all can see the right side of my screen. Terraform apply is complete. So there's 39 resources created. And yeah, it took quite a while. It took like 9 minutes plus almost 10 minutes to create the Beanstalk environment. And the code pipeline also created everything lah. So yeah, we can double check now on the right side of my screen. There's the management console. We open Beanstalk and we see. Oh, it's still updating. Okay, because code pipeline is trying to insert the new what do you call this source, right? From okay, it's already connected to GitHub, right? So if you can see my on the right side of my screen, the code pipeline, the stage, yeah, is connected to already to my GitHub, is some sample repo, and it will deploy, right? Unfortunately, when I tested this, it kind of didn't really work because I'm not very familiar with .NET applications, and I know from what I've read online is that when before you deploy, you have to build, and there's a deployment manifest and all that stuff. So yeah, I'm really not very good with .NET applications. I haven't really touched them, so I'm not really sure how to deploy. But I found the manual way. So I assume in the future, like let's say if we're doing this for real, right? Then after that, the engineer would have to come up with the deployment script, everything, so that it can work from the code pipeline and make it automatic deployment lah. So yeah, okay, I will just wait a while more for this to load. But in the meantime, if okay, in my Beanstalk environment, right, on the left side of my screen, if I click open the public DNS, Oh, service is unavailable. Okay, course probably still loading. Yeah, different version. Started application. Oh, okay. Yeah, let's wait a while. Yeah, okay. So if we see our code pipeline, deployment is successful, but actually it doesn't work. Okay, we should see first. Okay, so environment health is now green, right? In our Beanstalk environment, if we click open the link, okay, then you see the app, right? So in our public DNS, we can load this, but yeah, this is just the default application, all right? This is the default application that Beanstalk will deploy for us. And yeah, so everything is working. So if let's check the VPC, right, that we created through Terraform. Yeah, you can see that I have two different VPCs, right? One is the default one, and one is the one that is created. We go inside. Yeah, we can see, okay, the public subnets, right? 1A, 1B, you can see the private subnets that was created. And we see that there's two different, okay, actually one, two, total of four different routing tables, right? One public and then three private ones, because they each attach to their own NAT gateway. And there's one singular internet gateway, right? From the public route table and the public subnets. Yeah, then okay, so let's test the okay, I can show you guys the load balancer as well, right? Yeah. So yeah, we go to the load balancer, we see that this is the load balancer that was created by Elastic Beanstalk, and it is connected to two instances that were spinned up in 1A and 1C, right? Availability zone, I mean. And our cross-zone load balancing is enabled. So that means with each traffic, you'll load to either A or C, A or C, A or C, like that, right? And let's go see the instances. Yeah, two of them are running. So let's say we want to test, okay, if one AZ fails, right? So I just simulate that by terminating this. So let's try terminate instance for whichever one. Okay, we just do this one first. Successfully terminated. We wait for a while. Okay, it's gone, right? Stop running already. If I refresh again, it's shutting down. So because of the auto scaling group settings, right, we should have another instance that is spinned up automatically. We just refresh this a few times. In the meanwhile, let's see the auto scaling group. Yeah, so auto scaling group here, open. Yeah, we have a desired capacity of 2, minimum capacity 2, maximum capacity 4, right? Which is, I think it should be sufficient for the template, for this template. Yeah, okay, terminated. I refresh. Let's wait a while more. Oh, there you go. Oh my god, it took so long. Okay, yeah, so spending, right? This is created in the 1BAZ, right? And we can see that these instances is created in the private subnet, right? Which is best practice for in terms of security. Yeah, for this one also created in 1C. Yeah. Okay, it's running, still status check initializing. Okay, so we just assume it's working. Our Beanstalk. So I refresh. Yeah, there it says remove instance. It's terminated. You'll probably spin up another one. So not to worry about that. So yeah, so in terms of high availability, it's working. Load balancing works also. Yeah, so now we just want to see whether deployment works, right? Okay, so in Visual Studio here, I have a sample .NET application, right? So let's load it in localhost first. Okay, this is the .NET application that I want to deploy, right, into the environment, to the infrastructure. Right now you can see it's in the localhost. So okay, I close this first, right? Okay, so this is the part that unfortunately is still a little bit manual because I'm not really sure how to do this. But from what I'm from through the code pipeline and GitHub method, right? So in this method, let's say if I open this is the app itself, right? MZC5. So Visual Studio, they have this plugin where you can publish straight to Elastic Beanstalk. If I go here, I say, there you go, redeploy to an existing environment, right? So that is the Beanstalk environment that I just created. Let's go next. This part I want to change anything. Next. Okay. I just go deploy. Okay, then you have the status here. Upload complete, creating new version, blah, blah, blah. Okay. Then, oh, yep, the screen will come up of my Beanstalk environment. Then, if you can see at 6:45 p.m. here, environment update is starting. And yeah, let's wait for a while. Yeah, Elastic Beanstalk updating our environment, and you can see the environment update is starting. Yeah. Oh, there you see the instance was added just now, right? So yeah, we have high availability here, the fault tolerance. Okay, let's wait for a while. I'll pause the video again so we don't wait too long. Later we come back. Okay, yep. So we are back. We see from our Visual Studio, it says environment update completed successfully, right? So this is the .NET application that we want to upload, right? To deploy, sorry. And if we look at our Elastic Beanstalk, let's open the link. There you are. So, right. So this is our Elastic Beanstalk endpoint, right? Public endpoint, public DNS, and this is the .NET application that we want to deploy. So yeah, everything is working, but of course there are a few limitations. So let's go back to the slide here. Yeah. So yeah, as you can see earlier, right? There are some a few limitations. Okay, so here I didn't want to assume what kind of database that the engineer is using. So for now, there's no database provided or provisioned yet. And the cost of this infrastructure, of course, is not going to be the cheapest because if we see here, right, we have three different entity gateways. That's going to cost some money. Even my EC2 instances, I've tried to just keep it to a free tier T2 micro also. Yeah, so it's cost considerations. And in terms of security and compliance, so let's say if it is a government workload, right, it might not meet all the compliance requests for now. And the only like best practice in terms of security is so far we put all the EC2 instances in the private subnet, right? So they're not accessible to the private from the public internet. Yeah, and also this is really a very simple template, right? Like as I say in mine, like previously what I mentioned. And there's no also a public DNS, like a proper name. It's just one simple Elastic Beanstalk DNS. But yeah, so this is very, very simple architecture, right? And with that, I think it has met the five requirements. And yeah, the only part is, okay, let's say like the database, right? We need to spin up a new database. So they say one of the requirements is any changes must be performed without manual intervention. So in the future, if let's say it's an RDS database or like, I don't know if it's a MongoDB, like what you can, yeah, we can load them in from here, our Terraform code, yeah, to without like through the AWS console. Either all works actually from here. But yeah, so that's the end of my demonstration. I'll update the slides and include the actual endpoint link. And yeah, thank you so much.